Hello everyone, welcome to another data analysis tutorial by Team Slidescope. In this part, we will try to understand data distributions in simple words. So you must have seen charts like this, histogram charts or distribution charts like this while doing data analysis. This is normal distribution, uniform distribution, binomial distribution, Poisson distribution, exponential, skewed, bimodal and log normal distribution. So I will give you some examples what these charts are. So we learned that these shapes are obviously called data distribution and they tell you how your data is spread. So a distribution plot visually shows how data values are spread across a range. On x-axis, we have the possible values or intervals of the data set. For example, customer age, transaction amount, or test score. So that will be on x-axis, and on y-axis we have the frequency or probability density or count in simple words. Like for example, here the range is 0 to 10 and here is count of something. So how many people are or how many people have scored 0 to 2, you can count them, that 80 or 90 people have scored 0 to 1, 1 to 2 is scored by some 84 people. So that's how you will read this data. So first is normal distribution that you are seeing here. This is normal distribution. It's like a bell curve. So this is that perfect bell shaped curve we all know from school. Most of your data sits near the center with fewer values on the edges. Example is, let's say you take 1000 people, you are surveying them, you ask them their height, and you will learn that most of them fall near 5 feet 6 inch, and only a few will be too short or too tall. So most of them will be around 5 6. So let's say this is the lowest height, this is the highest height. Don't worry about these numbers, but lowest height, highest height, and most of them will fall near 5 feet 6 inch, and that's why this count is given. So on y-axis, so that is normal distribution, and only a few will be too short, few will be too tall, so that's why this type of shape appears. Then there is uniform distribution. As the name suggests, this one is super simple, all outcomes are equally likely. So example, if we roll a fair dice, every number 1 to 6 has the same chance. In this example also you can see we have numbers between 0 to 10 and most of them are around 80 mark. Like chances of happening or chances of getting these numbers is almost equal. So this is uniform distribution. Then we have binomial distribution. Think of it as how many times can I succeed out of n tries. So example, if I flip a coin 10 times, how many heads can I get? The result will vary, but they will roughly form a binomial pattern. So this is a binomial example. Then we have Poisson distribution. So when I first worked on customer support data, I used Poisson without even knowing it. It measures how often something happens in a time frame. Example, number of calls a help desk gets per hour. You can't predict the exact number, but you can estimate the pattern. So this is how it looks. Then we have exponential distribution. This one's about the time between events. Example, the waiting time between two buses at a bus stop. It's usually short, but sometimes you wait longer. So this is exponential distribution. I will share more examples in this article and share its link. So I'm just sharing some simple examples, but you can get more links. Suppose every day you are going from your bus stand to your office or a school, and this is your wait time. Sometimes you will get the bus instantly, but sometimes you may get the bus after, let's say, 50 minutes. So if you take data of 100 days, so most of the times you will get bus between 0 to 10 minutes. That's why here it is like that. So this is exponential distribution. Here you can see 0, 1 or more. Then we have skewed distribution. Not everything in life is balanced. So when data leans heavily to one side, it is called skewed. Example, income distribution. A few people earn way more than the rest, making the graph stretch to the right. So most of the, let's say this is a very high income, this is low income, and this is low to mid income or medium income. So that is skewed distribution, and it is towards right or left mostly. So then we have bimodal distribution. You must have seen graph with two peaks. Here you can see a bimodal distribution. So this type of graph is called bimodal. This means there are two groups hiding inside your data. Example is, if you mix test score from two different classes, one is strong and one weak, you will see two bumps. This is one example. Then there is log normal distribution. This one is like cousin of normal distribution but is stretched on one side. Examples are stock prices. Most stay within a range, but a few shoot up really high. So this is log normal distribution. A few will shoot up really high with some outliers. So what we have learned, the more we have analyzed data set, the more we realized understanding the shape matters more than the numbers sometimes. Before doing fancy modeling or applying formulas, we always visualize data first, and the distribution tells you whether your assumption even makes sense. So this is a very very famous Titanic data set where passengers who are traveling in Titanic, that we have their data. What if we try to see how age is distributed in this data set or fare is distributed? So in most of the cases we will take a numerical column, a numerical continuous column, and see its distribution. So here I am in my Google Colab where I created this code. This code is also shared. So we will import Seaborn as SNS. Seaborn is a library which has these data sets. So we can say sns.load dataset Titanic, and we will say this is df our data. Then if we write df.head in Python pandas, so it will give you data like this. It doesn't matter if you understand Python or not. This is just a data. When you are creating a distribution plot, you have to take one variable. So we will say age is equal to df dot age. So this will pick all age of these customers, and then we can create a distribution plot. So if we write df dot age dot plot, and we can say kind is equal to hist, which is short for histogram. So this will create a graph for you just like this distribution. Now what is this telling us? That in this Titanic dataset, all these passengers are from 0 to 80 years old age. Passengers who are from 0 to, let's say, 10, so who are in the 0 group, so these are called bins. And passengers who are in 0 group, there are 50 plus such passengers, like most of them are children. People in 20 bin, there are 175 people. 30 bin, there are close to 170 people. So most of the people are in 20, 30 and 40 bracket. Then we also have some other people who are old, 70 to 80 years old. So this is what it tells you. Here it is written frequency, that is count of how many passengers are there. If you see the data set, there are total of 890 passengers. So if you write shape, you will see how many rows are there, 890. So out of 890 passengers, how many are between 20 to 25, 25 to 30, 30 to 35? This is what it is telling you. So this is how you can read data distribution, and this is what we have learned here. So now next time when you will see this type of curves, you will be able to understand data, and you will be able to at least understand what type of distribution is it called. Sometimes in interviews also they will ask you these kind of questions. So next time try that. Thanks for watching this video. If you have learned something new from this video, please like this video and subscribe to our channel. We have a lot more data analysis related content than this. Thanks for watching. Have a nice day.